So now that you know a little bit about what a future task is, let's see how we can actually apply it in a context we've already discussed before. And we're going to talk about applying it to the Memoizer. And the purpose of this discussion is to show what you can do if you don't have Java 8 with the compute if absent method in order to get the same semantics. So we're going to talk about, we're going to recap Memoizers. We've talked about this before. So remember, Memoization is this optimization technique that's used to speed programs up by caching the results of expensive function calls, where if you come in and something's not already there in the cache, you do some long-running computation and then store the resulting value along with the key in a map and return the value that's associated with the key. Otherwise, if you've already computed this before, you just return the value. So that's what Memoization is all about. We are going to use the future task in order to be able to implement the Memoizer. So this is going to be a different implementation of Memoizer than what we looked at before. This particular implementation is based on the Java Concurrency and Practice book. There's a chapter in there that talks about using Memoization, and it's very, very similar to what we're talking about here. So if you've already computed the value, just return it. Don't bother applying the function unless it's not already there. As before, we implement the function interface so that Memoizer can be used wherever a function is expected. You'll see how that gets used in a second. Under the hood, we're going to use Concurrent Hashmap, except this time we're actually using the Java 7 version of Concurrent Hashmap, or the non-Java 8 version and beyond. So this is earlier versions of Concurrent Hashmap that lacked the compute if absent method. Now, Concurrent Hashmap, even from the early days when it came into existence in Java 5, has always been optimized to have a larger number of locks, which enable it to be scaled up more effectively in a multi-threaded, multi-core environment. So you have different locks protecting different portions of the hash table. So your likelihood of having contention is much lower because you're kind of partitioning the locking space up quite a bit. And that's in contrast to other, even earlier versions of synchronized collections like synchronized map, which only has a single lock and therefore becomes a point of contention. So we're going to have a method here called compute value, which is very similar to the compute if absent method that we looked at before, except this is going to use a future task to do it under the hood, rather than relying on this modern Java feature that doesn't exist in earlier versions of Java. And so it's going to use future task to ensure that a function only runs when a key is first added to the cache, and otherwise just will return the pre-computed value henceforth. What's nice about this, as was the case with the earlier versions, exactly the same semantics. If multiple threads were to simultaneously all call compute value on the same Memoizer with the same key, they would end up only having a single call to the function that computes the value associated with the key. So it's very clever not to allow more than one call to this function to occur, no matter how many threads call on the same key, the same non-existent key, simultaneously. Okay, so that's just a quick overview of what is going to happen here. We're going to look at the implementation in a second, but that's just kind of putting it back into context. So the reason we're doing this discussion is because earlier versions of Java lack the features of compute if absent in modern Java's concurrent hash map. So we have to show how to add that capability using previous versions that are in earlier Java releases.